All right. Welcome everyone to the 6th installment of the Ethereum Berlin Meetup by Linum Labs. Today we've got Foam with us and Dether, or Dether. He'll explain more later. Great to see you all. Great to see you all. Always some familiar faces and some new faces as well. It's always great. Bit about Linum Labs. We do community events such as this one, training, private and corporate, as well as consulting and development. We've also got some products in our pipeline since we started developing, but a little bit more about that maybe on another meetup. Logistics, if you don't know, the toilets are in the back. There's free beer if you haven't got a refreshment yet. And the event here will be live streamed, so no swearing. Pizza will be coming later, and if you have questions, there will be a Q&A as well, and the networking event later. And Alex here and Arthur, they're very approachable. Don't be shy, just ask away. All right, so first we're going to have Dether. Alex here is working on geospatial research and development. Dether basically helps connect people that want to sell or buy cryptocurrency and helps them to do so in the real world as a person, as well as helping stores accept crypto payments. So with Dether, you will be able to sell Ethereum in public to another live person, and to quote the webpage, just like if you were a mobile ATM. Foam there will be talking second. Foam is about bringing geospatial data to the blockchain. One of the key challenges in blockchain technology adoption is bringing its functionality to the real life and make it work seamlessly. And one important aspect of that is proof of location, verifying the actual location of objects so you can use them on the blockchain. So in partnership with others, they're developing protocols, standards, and applications, and we'll hear a little bit more about later from Arthur there. Alex?
Yeah. Thank you.
We need to switch. So, you want sorry about this.
No. Okay. Thank you. So, hello everybody. I'm here to present you Dether. So, Dether is a peer-to-peer ecosystem of crypto buyers, sellers, and physical shops. So, let me introduce myself first. I'm Alex. I am a geospatial data engineer. I do blockchain consulting also. And I'm a co-founder of Asset Non-Profit Association. If you heard about it, we organized HCC this year. Today, I'm heading up Dether map system research and development, and that's why I'm here today. And thank you for the invitation. You can follow me on GitHub and Twitter if you want. So today, why people need crypto? When you want to interact with decentralized application, like new services such as climate insurance, identity, arbitration court, or a lot more of services, you need to get crypto to interact with this new application. So this kind of application target everyone around the world because there is new kind of services which are dedicated mostly for people who didn't have access to this kind of services before. But today, to get crypto, to use this kind of services, you need mostly a bank account. It's a painful process, difficult. You have to do a wire transfer from your bank account to a centralized exchange really often. And what about if you don't have a bank account? Furthermore, cryptocurrency solves some financial issues. Sorry. For example, hyperinflation resulting investment in crypto. For example, the Venezuelan bolivar. The remittance, you want to avoid big fees and big delays from companies, and the lack of trust in national banks. So today there are financial solutions, new financial solutions which exist and which also require some cryptocurrency to interact with, like peer-to-peer lending and microcredit application. So how to make sure that everyone, especially unbanked people, have access to crypto? So today there is approximately 2 billion adults who are unbanked. But smartphone penetration is worldwide. So let's talk about Dether. Dether is a decentralized peer-to-peer crypto exchange network. It enables anyone to buy Ether with cash. So you can spend crypto, Ether and crypto, sorry, and you can spend the crypto at physical store nearby. So there is a smartphone app, and the app is based on a map. So Dether is basically two components: the protocol component and the application component. The protocol component is composed of Solidity smart contracts, which are deployed on the Ethereum network, and there is a Dether.js library, which is useful to interact with the smart contracts. But you can use these smart contracts and Dether.js without using the mobile application. You can build your own interface if you want, or interact directly with the smart contracts. And so the other component is the application. It's a smartphone application, a progressive web app. It's not installable through classical store like Play Store and iOS Store. I don't know. You can install it through your browser, and it's done like this to avoid censorship of stores. And there is also a backend for the application which listen to events of the smart contracts and who populate database for display purpose. So the onboarding on the app is the simplest onboarding as possible without neglecting security. So there is a backup phrase which is generated. It represents your seed, and so in background it generates private keys, and so you have to type a password to encrypt your private keys. So even if your phone is you lose your phone, sorry, and someone found it, he can't access to your phones because he doesn't have your password. So phones are safe. So it's classical wallet application, and during the onboarding, simple KYC is done with phone number today. It's supposed you trade under 1,000 euros per day, and if in the future user want to trade more than 1,000 euros per day, there will be a more complex KYC. It's for regulation purpose. So the app can also be used as a wallet, which is a user-friendly wallet. So in this, did it work? Okay. So you can see there is currently Ether, DTH, and DAI stablecoin, which are listed on the application. The application is usable today on betacovan.dether.tech. So when you click on your wallet, you have your wallet address, and so I provision my wallet with some Covan Ether, and I use a DTH faucet to get some DTH from Dether DTH faucet. So this is the view. The app is based on a map. So this is the view of regular user view. So you can see on the map there are sellers. These people can sell crypto. So there are physical sellers which you can join on encrypted chat. Today is Telegram. In the future, it will change. This is reputation based. It will be reputation based, and so you will buy some crypto with cash to these sellers. And the app list also shops which accept crypto. So this is a shop. So let's talk about the Dether token model. So there is the DTH token, which is a utility token, which is already buyable on exchange. But there is also a reputation system based on loyalty points. The loyalty points are not buyable. They are earnable if you have a good and active behavior. The shops which are listed on the map and which accept crypto have to stake DTH to be listed on the map. If they don't want to, if they want to be delisted, they will take their stake back. A stake amount is depend of the number of shops around and other factors. For sellers who want to sell crypto, sellers want to operate in a specific zone. So Dether target professional sellers and not classical public sellers. So sellers have to stake DTH also as a license to operate. You can think as a taxi driver license to drive a taxi. And but they also have to own loyalty points, so good reputation, to own a zone. So if they have good reputation, they can own a zone and sell crypto on this zone. The sellers earn loyalty points with the number of the trades they do, if they trade with different people, and the amount which is sold per day. So when you are a seller, you can register. You can register your zone. You can say, I want to take 4% in fees, or less or more, and the amount of Ether you want to sell today. So I go quickly on these steps, but on this slide, I sold my first 200 euros in Ether to another guy. And then you can see here in the wallet that I have less Ether than at the beginning because I sold part of my Ether. And I have less DTH also because I staked 20 DTH in this case to own a zone in which I can operate. So I keep my zone, so my DTH are staked, but at the end of the working day, I can, if I want, to avoid loss in the night because of the volatility, to exchange my Ether against DAI stable coin. So yeah, I can protect myself. So that was the main application. But in this kind of application, you think about map key issues. So cryptocurrency buy and sell today are not regulated like the same between countries. The regulation change between countries. And the platform, the selling platform, must have the possibility to geographically restrict the trades based on location. So to be country compliant with the local laws, you can also think about filter authorized token by countries. So think about security token, which is forbidden in some countries, and utility token, which is not a problem. So depending of your country, you may have to restrict which token you need to exchange. Also, in some countries, you have a limit you can spend in cash per day. In some countries, it's 1,000 euros. In other countries, it could be less or more. So it could be nice to filter depending country also for that kind of problems. So to do that, we maybe need a way to represent a country, a real geographical country on Ethereum, which you can request and make valid location check. So today the problem is that geospatial data is huge, and spatial queries are really complex, mathematically costly, and it's not really possible on Ethereum to use the same classical piece of software as usual to do this kind of things. So in Dether application, when a seller had a selling zone, he had to give the coordinates of the zone he wants to own, and he has to specify a country which is supposed to be the same as the coordinates he gave. But how Ethereum can verify it, today it's not possible. So you can restrict it in a client, so basically in the mobile application you can do it. But the goal of Dether is to provide a protocol that you can interact with without the mobile application if you want. So to be really decentralized. So if you didn't understand what I mean by verifying coordinates within a country, I give you an example here. So if a seller declares he's in Kenya, because regulation is maybe nice in Kenya for crypto, but he told the app he registered in Kenya, but he put his zone in United States to trade a security token. It could be really a problem for the platform. So that's this kind of check we want to do in a decentralized way. So we built a proof of concept last month, which could be called country permission management or proof of country inclusion. And so there are two goals of this proof of concept. First one is to store countries in Ethereum. And the second one is to check if a seller zone is inside a country, but it has to be checked by the smart contract itself. So to achieve it, one way could be to use XYZ tile server standard. I don't know if you know it, so I will explain you a little bit what is it. So today, when you request a map on your browser or on a mobile application, the client requests some tiles to a map server, to server which serve maps, because it's the name of server also. So XYZ standard is just a standard which change tile grid coordinates by zoom level. So at the first zoom level, you have only one tile of 256 by 256 pixels squares. At zoom 1, you have 4 tiles, so you have 4 more tiles than at the previous zoom level. At the zoom 2, you have 16 tiles, and it continues. When you zoom on the map, you will have more and more tiles. And so we thought that it could be interesting to use this kind of standard with the coordinate system. So you see here it's 3, 3, 0, 0, 3, 0. So we can use it. This is the list of the different zoom levels which are supported by application, standard application, and we interest ourselves in the zoom level 12, which there are 16 million different tiles with a precision of 10 kilometers. So this is the border between Congo, Brazzaville, and Congo, Kinshasa, and these are tiles of zoom level 12. So this size of precisions seems convenient to define a country by filling countries like that. So we can define countries with this precision. So it's not really accurate, but we have the constraints of Ethereum, and so we have to deal with it. And so this zoom level seems acceptable. So what we did is that we generated squares like that, like the green squares for the whole world with Python scripts and geospatial libraries. So there are 6 millions of squares. And we took open spatial data, natural Earth. And so we put all that stuff in a geospatial database, which is called PostGIS, GIS. And we did some kind of spatial intersection, because the database provides some SQL functions to do this kind of stuff really with a spatial indexation, so it's really quick and efficient. And so we extract this kind of map. So it looks like the Congo. But it is the Congo, but it's degraded. It's a low quality Congo. So here's the Congo with 12 zoom level 12 squares. So each square of Congo has a top left coordinate origin, which is this, for example, 2221, 2097. And so we can use it to deal with the data. We have 10 kilometers precision. That's approximately the this I am drawing now. So, but we accept that in the application because we don't have the choice now. So this kind of data structure can easily be stored in Ethereum. So our strategy to store it was to index it by X. So X are columns, and Y are X are lines, and Y are columns. And we index by X, so by lines. For example, the first coordinates of Congo is this column. We take the first square and the last square, and we store it like that. When we have all like that, we store 2 columns. So this is a mapping. Bytes 2, it's to define the country code. So for Congo, it's CEG. In Hexa, I don't remember the number. And then the mapping, this unit is X, and this arrays are Y. So in case of multi-column, that's why this. So this mapping is countries we define on Ethereum. So this is the matrix, the whole matrix, which represents the Congo. So you see it's not so huge, and we can deal with it. And so what is in red here is in red here. Each column is stored in the matrix. So we achieved the first goal, which was to store a country in Ethereum. Bad thing is the accuracy of the country, but the good thing is that the country is stored. So now it's really easy to check, to verify if a zone at zoom level 12 is inside the Congo. So I put 2 examples, one which is outside and one which is inside. And so we just have to take a look at the matrix we put in Ethereum to know if the zone is inside or not. So if a seller try to register this zone inside the Congo, he couldn't. But I explained to you that we want seller to own some zones. But selling zones are really smaller than country zones. So here I put convenient selling zone. So it's really so it's Gibraltar. It's a small zone which can be owned by a seller. So we took the zoom level 18 to represent this kind of zone. So if you don't have the idea of the difference between zoom 18 and zoom 12, this is the difference. You have the tile at zoom 18 here, and the big tile, which we use to represent the countries, which are really big. And our problem is to make sure that people who register a selling zone, so a small zone, is really inside a country. So we have to take the parent zone of this small zone, even if the zone is here or here or here. The parent zone is this one. And so then we can take a look at the matrix of the country. So if you remember, the factor between zoom levels is 4. So zoom 0, you have 1 tile. Zoom 1, you have 4 tiles. Zoom 2, you have 16 tiles. So the x factor is 2. You multiply x by 2 here, from zoom 0 to zoom 1, and the same for y. And 2 by 2 is 4. So if you want to convert tile from zoom 18 to zoom 12, you just have to divide by 2 the number of zoom levels. So this one is zoom 18, 17, 16, 15, and 12. So when you just have to make this kind of division, and you can get the parent tile of the child tile, which is a selling zone, to be sure that the tile is inside another tile of zoom level 12, and then compare it to the matrix of the country you pushed in Ethereum before. I hope it's clear. So we solved this problem. Now in the application, it already works. It's already working with the Congo. So we can put zone outside of the Congo and inside of the Congo, and we can throw people who try to cheat on the application in a totally decentralized way, thanks to this. So next steps will be to calculate how much it costs to store a lot of countries in a smart contract, maybe to optimize all that stuff. To add maybe spatial queries if you have special needs, or if someone want to add special queries to the smart contract, maybe it can be nice. And we will deploy some other countries on Ethereum, but we will focus on the country we will use in the Dether app at first. And then if it's not cheap, maybe we can deploy the whole world. We just have to take a look. It's really fresh research because it was done last month. So it's not really complicated, but it could be useful. So, yeah. And what's next for Dether? The new website is coming soon. The release on the Ethereum mainnet will be in June. It won't contain the research I present to you now. It will be maybe in the next release, but not in the June one. We'll list more crypto in the wallet. And we will do other POC about geospatial stuff. So with zone claims, what is zone claim is when I'm a seller and I own my zone, if you have a better reputation, more loyalty points than me, you can take my zone and sell, and I disappear. So this is zone claim, and delegated zone is if maybe I'm too busy because there are a lot of people who want to buy crypto on my zone, I can delegate to you part of my zone. Or if I go in holidays but I don't want to release my zone, I can delegate it. So yeah, we will work on these features too. And Dether is hiring. We will also be in Phosphor-G in Tanzania in August. This is the biggest conference in open source geospatial software. So we'll speak maybe in the conference, maybe giving a workshop. And so that's all. Thank you.
All right, we're going to do a little Q&A now for like around 10 minutes, focused on your project.
Okay.
How to repeat the questions?
Yeah,
Okay, I repeat. Yeah, slowly.
How do you protect against fraud? Fraudulent country registrations by groups of people?
Yeah, I really focus on geospatial stuff, and I didn't. I don't have a. I'm pretty new in this year, so I didn't address all these points. Yeah.
So, to me, it became clear that the Dita token is only used for staking, and that's the only utility I understood so far. And in that case, why do we need a native token? Because you could stake another currency. Or is there any other utility that I didn't catch?
I hope I will try to answer the question. So basically it is the business model of Dether is based on ICO token sale economy, and the token which is used is a utility token to make the app working. But I don't know myself why there is.
Can you maybe, that was right at the beginning, can you maybe quickly explain how the exchange works? So is it a seller trades crypto for crypto?
Yeah.
And if you trade crypto for crypto, how do you take care of gas costs? Do all of your users need to have Ethereum in the wallet? Or?
So if you trade crypto for crypto, you have to pay for your gas, I guess.
So you need to have Ethereum in order to do any transaction?
Yeah.
Are the contracts just for registering zones, or is it also used as escrow for when you actually do the exchange, or do you just have to hand somebody cash and then wait for them to push the button?
So do you mean the country's contract, or sorry, I didn't repeat the question.
I see that you use the Solidity and the blockchain for registering zones.
Yeah.
I was wondering if there's also use of contracts as an escrow service for the actual exchange, so that there's sort of a middle ground between handing over cash to somebody, or is it just the human interaction?
It is just a human interaction for now. Yeah. Yeah.
What are you using to determine the prices that the exchanges are happening in?
Can you repeat the question, sorry?
What is the exchange rate based on? Like, what are you using as the...
Okay, there is so the question was about the exchange rate. So there is an oracle which take a look at the exchange rate of Ether price at yeah. Yeah.
Why does the geospatial data have to be on the blockchain? Is it to prevent fraud, or it seems like a really expensive way to like...
Yeah, so geospatial data have to be on the blockchain, that's the question, because if you need to use the smart contract without the mobile app, you can register a zone in a country where regulation is not so nice, and so it's risky for the platform.
But I mean, how do I say? I understand that, but like if you just spoof like your location, what protections does putting your
Yeah.
location on
You
blockchain? What protection does that use? Like why go through the cost of that?
so the question was if you just proof your location, why do you do that?
Yeah.
Yeah, and but how to prove your location within the app? No, the good answer I think was it was to restrict the usage of the app in some countries, because when mainnet network will be launched, it will be launched in countries which are with regulation crypto crypto friendly regulation, and we have to restrict the usage of the smart contract in this kind of countries, and so we couldn't do it in another way than this way, I think.
I think he meant spoofing. If you fake your location, like with your phone.
Oh, it's not based on GPS,
How
so
can it verify that you're actually there?
so if
If you're not there, then you can't.
yeah, you can't sell. If the question was if you fake your location, but if you register a zone to operate, you are there to sell your crypto. If you are not there, so maybe your stake will be burned. So yeah.
Okay, so does that maybe lead to censorship attack because you are just transmitting locations over the Ethereum network, and the Ethereum network is public blockchain, as you know?
Sorry, can you repeat the question?
So it maybe cause a censorship attack
Yeah.
for a large people that is using your app.
Yes.
Yeah.
Yes, it is a censorship from the.
So how you can protect the privacy of these people?
So privacy of these people is not. The KYC is protected. Today, the KYC which is done is encrypted, and we get it in a centralized way. And tomorrow, we hope we will use decentralized KYC like UPort and something else.
So you can also use something like zero knowledge in order to preserve the privacy of
Yeah. So research has not been done on this point yet. The main focus was to launch the app, but in the future we'll take a look at every possibilities. Yeah. So yeah, last one, yes.
There was this problem that you had to divide the map into squares,
Yeah.
because that way you can compute the location more simply. Otherwise, you could have actually cut the zones at the border into non-square shapes. But I guess the shape that this object would have would be very hard to represent on
Yeah.
the blockchain, and then it becomes computationally expensive. But if you can do all these computations off-chain, and you just have off-chain computation layer that says 1 or 0, whether you're in a zone or not,
Yeah.
then you can actually represent the borders much more cleanly.
Yes. For the first release, we thought about this off-chain calculation, but we were aware of that, but we wanted people who can interact directly with smart contract without the need of an external server to do off-chain calculation, because the app is focused on unbanked people, they maybe don't have. So this is a mobile smartphone generation. So yeah, okay.
But you're required to have the whole blockchain on your phone in order to be able to determine that you are in the zone or not.
The beginning of the question.
Okay, so is it required on your phone, on your app, to have
So
In order to be able to discern whether you are in the zone,
no.
that because I mean it's kind of I mean you do on-chain stuff and how do you have the chain stored on a server or do you
Yeah.
have it locally on a phone? It's
Yeah.
kind of confusing to me.
Yeah. Today, transactions are broadcasted. In the future, maybe there will be like client inside the app, but it's not done yet. So, yeah.
Men dan voor sorry, you have to have that whole blockchain on your phone to be able to do this.
So today, no, because the transactions are broadcasted, and yeah. But you can interact with a smart contract, having the whole blockchain on a server or on your phone if you want. You can interact with contracts.
Yeah, I was just wondering because this beats the whole point of centralization and
Yes.
like you mentioned.
Yeah, you're right. So today we are aware of the centralization, and we will try to avoid it step by step. So yeah.
Okay,
Thank
two
you.
more questions. Let's take one from the back here. Just speak up. Yeah.
Thanks. If I understand correctly, your problem on the if you understand correctly, you save the tile and the zoom due to storage capacity on Ethereum.
Yeah.
You do that, but why don't you save the latitude and longitude as a coordinates, and then you can infer from that the country?
Yeah, because latitude.
The capacity storage will be huge for that.
So latitude and longitude. The question was, why don't you store latitude and longitude instead of saving squares on Ethereum? So if you save latitude and longitude, how can you check that you are in the country you pretend you are? So you need to, with latitude and longitude, to have a kind of reference to take a look into and to compare coordinates, but you don't have this kind of registry today with latitude and longitude on Ethereum.
Yeah, you're right, but it's the same for your tile. For your tile, you don't know at this zoom variable, at this square, you are exactly in this country.
Yeah.
But because you have that.
No, so we store the squares because it's simple to request the square more than latitude and longitude, we thought, but we are open to other solutions and we can discuss it after, of course.
One more question? Yeah. I just moved from back to forward.
All right.
Okay.
So I see the plan. You have later you will have enable the people to claim for the zones.
Yeah.
So what's like the benefits for people to claim for the zones?
So if there is the question was what is the benefit to claim for a zone? So the answer is if a seller is not as efficient as before and another person have a good reputation, he can claim the zone and he will be more efficient. So it's win-win for everybody except the person who was there before.
But mostly for reputation. Not for like transaction fees he cannot get from the fees wallets.
So you can claim a zone if you have a good reputation, better than the other seller. So thank you very much, and sorry for the question I couldn't answer. I'm free to discuss after the form presentation. Thank you.
Arthur, gonna show us foam.
Okay, wait, I'm just gonna quickly do this. Okay. And then, Okay. So, wait, do you have the remote still? Ah, okay, great. Hi, everyone. My name is Röing Baer. I am the creative marketing director of Foam. Does this work? Yeah. Okay. So, we're based in New York and Berlin, among other things out of this space, and we build geospatial standards and protocols and proof of location for smart contracts and blockchains. What we do specifically is we build these three elements. I'm going to go through them one by one. They're distinct elements. They work very nicely together, but you can also use them individually. The first is the cryptospatial coordinate standard, which is a way to link a location to a smart contract in an interoperable way. It's a standard proposal. We're working with the OGC, which is the biggest standards organization for geospatial standards on it. The second one is the spatial index, which is a way to visualize and interact with these cryptospatial coordinate smart contracts. You can think of it something between a Bloomberg terminal and Google Maps. And the third, which is kind of our flagship element, is proof of location, which we divide into dynamic and static proof of location, but I'll go more into that. This is important because of, as was said earlier, as soon as we enter the real world, we need to, geospatial data is extremely important. If it's from mobility to validate location of self-driving cars that are paid through a smart contract, from gradual supply chain payouts, a local government wants to act on, that wants to attribute data to geospatial coordinates in their city and act on that when they plan the city, from data attribution for Internet of Things and also data attribution for geospatial data markets to automated smart contracts for insurance. Geospatial data is extremely important. So I'm going to go through the three elements that we're proposing by going through the three problems that they're solving. The first one is there is no location standard right now for how smart contracts deal with geospatial data. So we propose one. We're working with the OGC, the biggest, and other companies on basically setting a standard. So that a smart contract that is, has a place, also can claim that place. Geospatial standards today isn't a solved problem. Addresses, billions of people don't have addresses today. There's people working on that. Most of the interesting solutions are proprietary, and most of the other interesting solutions that are open source are not funded. So through the other models that we're developing, we see also capacity internally to be able to develop a location standard. So one interesting one is, for example, what 3 words, which for location give you 3 words. They're used by countries like Bhutan. The problem is that they are proprietary. So not a great system to build your address system on, in our point of view. Geohash is another one that hashes longitude and latitude. And our proposal, cryptospatial coordinate, is another one, which basically takes an ETH address and a geohash, combines it, and now you have a smart contract that is also a location. And this basically introduces a spatial dimension to the blockchain. This is the first basic step, and we basically have this registry now of cryptospatial coordinates, smart contracts that are bound to location. So this can be real estate usage to insurance. The important thing is here that they're interoperable and can communicate to each other. Okay, so next element is the spatial index. The spatial index takes all the cryptospatial coordinates and puts them on a map. So you can visualize it and you can interact with it. So it's a full stack visual explorer for geospatial smart contracts on the blockchain. And any smart contract that uses the CSC standard will now be visualized through this. We're building it on a functional language called PureScript that compiles into JavaScript. It's a general purpose web app. Anyone can reskin it and use it for their own application. This is also not tokenized in any way, so you just use it. There's an open API, and there's a developer resource, a developer at .foam.space. So I suggest you check it out. And it looks like this. And here you have different smart contracts, and you can interact with them. Yeah, that's basically it. So the third one and the main part of the project is proof of location, which is if we have smart contracts that want to act on geospatial data. Let's say you have a gradual supply chain. You want to do gradual payouts for a supply chain system. You want to know if the truck arrives at the point where the smart contract wants to pay out a payment, or you want to know if you navigate somewhere on the spatial index, is the thing, let's say Google Maps, decentralized Google Maps through a spatial index, is the thing really at the location? Which is, of course, Dether is also struggling with these issues. So we have two different proof of location principles that we're proposing. The first one is static proof of location, which is for points of interest. What we're doing here is we're using token curated registries. We're proposing to get to token curated registries to have an up-to-date list or up-to-date lists of interesting points of interest. So a hiking trail list, or a list of Dether stores, where a customer wants to ensure that the store owners are still active and they're reliant. So you have a list for that, and then you can have. So basically, this is what it would look like. You have these points of interest. Let's say, for simplification, these are all Dether stores. I don't know if that's the density you're going for. I hope so. But so basically, these are Dether stores, and you can navigate them. Now, this is not a store, but you get the point. And you have customers and sellers. But we introduce a third party, which are called curators, or we call them cartographers, which can basically challenge entry points into the token curated registry. And this is the interface, how it's going to look like. So they can navigate between challenge, pending, or valid points of interest, and then bet on if they should be accepted or not into the list. And then you have a filtering system. We're going to go through more of this, hopefully at a token curated registry meetup here in Berlin, which is a great meetup if you want to learn more about token curated registries. They had one yesterday. We're going to go through more of that now. Then I'm going to go to the next one. The next and maybe most ambitious part of proof of location and that we're proposing is dynamic proof of location. And the problem we kind of have generally when trying to write self-executing contracts that deal with geospatial data is that this system, while being extremely amazing, this is the GPS system, is basically trivial to falsify on the client side. So as soon as you have value in the smart contract, people are gonna fake their location. You can just download an app today. So we saw this with Pokemon Go. We have Uber drivers in Lagos that fake their GPS location to get you charged more through an automated process. And we think that we need a secondary system which functions similarly to GPS, which is based on radio beacons that also uses triangulation, just like GPS. And we want to use these kind of systems exist today, but they don't have the incentivization models underlying them, which means that we can reach a density and people setting them up themselves yet. So we want to use tokenization for that incentivization. And we basically, our solution encompasses synchronized clocks and triangulation, similar to the GPS system, based on radio beacons. Low power wide area networks, so this is a type of radio. And crypto economics and incentivized proofs as a way to validate and ensure verifiable claims within the system. So we're proposing a system that is positioning fault tolerant, independent of GPS, trustless, and uses staking as a mechanism for deploying punishments and rewards. The way this works is that if you have a radio, you set up a zone anchor, you synchronize with local zones, local zone anchors in your area. You all stake into one zone, which is a service level agreement between radios locally, and then you can start delivering proof of locations, also called presence claim, to agents that go through the area for a microtransaction. We have a token that is only used for staking, so that a service provider gets their investment slashed if they act, if they're evil. So yeah, that's basically that. What we're focusing on right now is stress testing a special kind of radio, which is a combination of extremely long battery life and long range. They're called LoRa. They're small. They're like this. In perfect environments, which is not urban, they can go up to 15 kilometers. Within urban, maybe 5. So we're stress testing them right now, especially on time synchronization. So because the resolution of accuracy based on the location is based on how good the clock associated to them is. We're testing that right now, basically. The one thing that's interesting about LoRa is that there are already existing networks of LoRa devices deployed in different cities. And there's a system called, or a community called the Things Network, that are deploying these chips globally without any incentive structure. So these are just hobbyists that do this. What we're basically proposing is an incentive structure that can grow this network even further and then use that for proof of location. This is Sydney today. This is Zurich, which has the most nodes. This is if I set up one node here at Trust, one at our new office at Full Node, one at Factory, and one at my home. So I just want to give an image of this. Sounds like a really ambitious plan. It's pretty easy to cover large areas pretty quickly with these zone anchors. And within the system we have this token that is used as staking for the service level agreements. It incentivizes, so we basically distribute block rewards based on location for people setting up these radios. And it incentivizes good behavior through slashing conditions. And the result is a trustless, independent, open, and accountable, and incentivized system, which provides proof of location without client-side faking, basically. Foam is positioning itself as developing protocols and standards. So basically any of these applications and protocols are free to use, and we see an ecosystem of apps being built on top of them, which is also why we're building the first two examples without the elements without any tokenization, because they also help build the ecosystem that we want to see grow on it. This is our office in New York. If you're in New York, please write us, come by. We're going to move into Full Node as well, and we're sitting here at Trust as well. That's it. Thank you. I eat the mic. Okay, I should eat the microphone more. Any questions? Yeah. Okay. Do you want to delegate the questions, maybe?
Yeah, you start.
Just as a quick question, the LoRa bundles is prohibited in some countries.
Yes. Yeah, there is a regulatory problem based on different countries. So I know that LoRa has, we have our first community in Australia, and they're researching. So we have local communities that are researching regulations based on their country. We know that some countries have so LoRa device can only be active 1% of time. We're looking at that individually, case by case, and then kind of adapting to that. We're still doing a lot of, so we're pretty early, but yeah.
Is the protocol that the way you get a location, is it synchronous or asynchronous between the stations?
So between the stations, you have it's synchronous. And then we're working with Tendermint to do state machines that are, I guess I'm not a developer, but semi-synchronous, is that what it's called? And then we have an asynchronous root chain where we do slashing and staking.
But to get the location, is it like, do I just listen to a signal, record it, and then submit?
No, it needs to be. It's yeah. It's yeah.
So the LoRa network basically just is like a lot of little things broadcasting a signal, and then the position is actually computed on a moving device. Because then that opens up the same kind of fraud thing.
No, it's a two-way communication.
So I don't know the question.
What? Oh yeah, he asks if basically you're asking if it's a two-way communication or one-way communication. The actual proposal is that it's a two-way communication, which is why the presence claim is also pushed to on-chain by the.
Like a GSM network kind of thing.
But it's hosted by individuals. Yeah.
GSM is obviously centralized because it's operated by one GSM. But I was just wondering whether because you treat this as something that's like a GPS network, which is unidirectional, and that's why I thought I'd ask.
Okay. Yeah. Thank you for clarifying that. If that was unclear.
It's basic mechanic that each node has a private key and will kind of sign a statement that says this person asked me for their location at this time.
Yes.
That transaction can be decoded on Ethereum and kind of say, oh yeah, it was public key of this person that we registered, so therefore we know they really did sign this transaction at this time.
Yes. So basically, you will have a log of your own presence claim that you can disclose at any moment, and they will be linked to your key. Exactly.
As you mentioned, that one of the biggest problems is clock synchronization.
Yes.
For the different gateways. And how far are you down that road? Because no one has solved it yet.
That's a great question. So we're stress testing right now. We have a hardware partner, and we're stress testing. Yeah, the question is basically how far down we are the rough road potentially, or of time synchronization over LoRa. Is that what you asked? Yeah. We're stress testing right now with a hardware partner.
In the meantime, are you using Google Rough Time to get somewhere close?
Very good question that I don't know the answer to. I think I've read in our own documents about Google Rough Time, but I don't know if we're using it or not.
About your first part, where you
Yeah.
said you could define points and locations.
Yes.
Also define areas, perhaps volumes, routes.
Thank you for that question. That's a great layup. So we're actually working with. Okay, sorry. So the question is right now the CSE standard that we're proposing is based on points, right? So that's great for a lot of use cases, not so great for some if you, for example, want to do zones for, again, Dether. So we're working with the OGC, which is the Open Geospatial Consortium, right? On looking at what are all the needs from the blockchain space and how can they be used, how can they be incorporated by one standard or several standards. So we're open to also seeing how the CSE has to adapt to, so one would be Polygon based, one will be, there's formats like well-known text, for example, that might be one solution. We're looking at it, and then we're in active discussion with the geospatial standard makers.
Tell us something about your roadmap. When will you go on mainnet or have a token available?
Great questions. Legally problematic, but I think we're going to do a token sale for the tokens that will be staked, and shortly after that, we will launch a mainnet, and there will be directly a use of the token, and that's going to be specifically the token curated registry, and the something we call signaling, which is staking tokens in an area. That will manifest as block rewards for the radio system that will be set up later. But those are the first steps, but I can't give you dates on that, unfortunately. Any more questions?
So are you using GPS data and your own system, like LoRa system?
No, we see it as a supplementary system to GPS. We're not using GPS.
You're not using it?
No.
Is there data about parallel usage of GLONASS and GPS?
I don't know. Right, one here.
Is there or could there be a centralized competitor to what you do and that also ventures into proof of location and is a trusted company like Google? Or
Potentially, I think the question is if we what would it look like if a centralized competitor would try to enter that market. I think the amount of there is a beauty of space being fairly distributed, especially within urban environments. So if that in itself creates a barrier for centralized entities, whereas economic decentralized incentivization might not. And that's one of the things we're betting on, basically.
Would it be like a program where I can participate and have like one of those nodes behind?
Yes. So Thank you for that question. Also, basically the idea is that just like mining on Ethereum today, we will not be manufacturing any nodes. We will set up the protocol and set up the economic incentive models for people to build their own, or third-party developers or manufacturers to service with radio beacons. And as I showed with that nice thing over Berlin, the idea is that people can set them up in their own home and cover the cost of their purchase and put it hopefully more.
How do you position yourself in comparison to Helium?
Good question, because they went out a few days ago with a big statement. It came out how many days ago? Yeah, we want to look at it more before positioning ourselves, I think. But it's a good question. We've been a little bit in contact with them before, but yeah.
can you talk a bit about a killer application that would, like, what is the ideal scenario in your head where
well, I think all the applications that might come out of this directly are not replications of the apps we see today, because client-side verification of location is very easy. Something that would be very cool to do, easy, and many people can understand, is just like Pokemon Go, but the Pokemons have actual value. That's because you can't on the client side fake the location, and then you can, let's say, CryptoKitties with the location aspect. That would be a I'm not saying this is an ultimate maybe application. I'm just saying that this is like a easy first implementation of it that also might and then stuff like supply chain. Well, yeah, decentralized systems that need accurate that have value attributed to them and want automated payout systems or non-fungible tokens. Are there any more questions? Okay, yeah.
Sorry for occupying so much time.
No, it's great.
So if you don't use GPS, how do you locate the gateways in the first place?
Good question. So
you can use a mesh where they talk to each other. I think you even mentioned that in the white paper.
yes.
But how do you get it precise?
So the question is, how do the nodes, the radio beacons, locate themselves if they do not rely on a third-party service for initial location? So, as you said, there's basically a mesh. So you set up a system in an urban environment, and then they relate to each other by continuously pinging each other. The second one is if you want to set up a node system in a non-urban area, right? And there it gets complicated. Because if they only have a relationship to themselves, they could be floating or they could be on the Antarctic. The thing is, just like the Dether network, the value of that becomes very small if they're not where they're saying they are. And we're looking at incentive mechanisms, a little bit maybe like a challenge from a token curated registry perspective, where you can challenge zones that are not where they say they are. So we're looking at ways to look at that. If that is, but I'm happy to chat about that afterwards. Yeah.
How are the people incentivized again that run these beacons?
So there's two ways of incentivizing setting up as a radio beacon. The first one is that we have block rewards. So to first get the system bootstrapped, so I was talking Swedish, so to say, is by basically you get foam tokens if you set up a zone. That's one, and the second one is while we are not taking any what's called percentages of transfers for producing the presence claim, zones can add their own, whatever they wish, take charge money from the people that want presence claims from them. So basically, it's a market for producing presence claim where you will get transaction fees or presence claim fees. So that's the two incomes.
You are using bonding curve for specific duration registry?
We're developing our own ranked system. That's yeah.
So it's open source.
That's going to be open source. Yeah. I think everything we're producing pretty much is open source. Maybe not yet everything, but we're slowly releasing. The spatial index stuff is already open source. Okay, I think that's it, right? Okay, great. Thank you.
Pizza should appear in like 10 minutes. In the meantime, Arthur is gonna just say a few words to the location here. The Trust Place, House, Hub, what is it?
Oh yeah, thank you for that. So Trust is this. This is I'm running this with a few other people. We have desks and we're doing events like this. You can sign up on our newsletter on trust.support. And yeah, we're doing interesting things like this with experimenting with non-fungible token and natural assets that will grow here, which is not a joke. This is what we're happening. There's the Oracle right there. So yeah, sign up to it's not taking photos right now, but they're, yeah, so sign up to our newsletter and sign up for future events. Looking forward to having you.
Crypto flowers? Yeah. Look into flower tone.
All right, thank you very much for coming. And we're going to clear up a little bit on the top here. And yeah, thanks. Networking now. Don't be shy.